Okay, this is a bit of extra work for us, and it helps us understand what happens with heat when it interacts with matter. Now, what we've got to think about is there are two things that happen when we heat something, and we must get the right idea in our head. Some people get the wrong idea, and this affects what they actually think and how they actually answer questions on it. So let's look at what's going on. Hi, and this is something that will help you understand what goes on in change of phase or change of state. So I need you to think about this. Now, we've got a lovely picture of a crystal up here, and we can see a nice solid going on, and so we're going to look at what goes on actually inside the matter for us to better understand what happens when we apply a bit of heat or thermal energy to it. Basically, all matter is held together by forces, and attractive forces at that. So we've got these two things, or multiple things, holding things together. Now, we normally call these, in terms of matter, we call these chemical bonds. Now, we haven't done much about chemical bonds at all. You might have done a little bit in Year 8, I'm not sure, but we're working with that anyway. Now, these bonds are important because that is where energy is stored, and it also means we must use energy to break them. We use energy, we provide energy and put in energy to make them, and we put in energy to try to break them. So it's a really interesting thing, and this has a lot to do, it doesn't sound like it does, but it has a lot to do with the effect of heat energy or thermal energy on matter. Now, some people think that when we heat and when we change phase, certain things happen. I'm trying to allay those thoughts, and we're going to work through a little bit now. All right, let's look at a basic part of matter. Let's look at water. And I've got the picture of water here, and we can see that it's H2O. All right, this is where it comes from. We've got two hydrogens here and here, and one oxygen here. All right, so we can see where things come from, and this is why it's called that. And we can see there are these lines here, these blue lines, represent bonds or joins between them. So there are two bonds, one bond between each of the hydrogens and the oxygen. Notice there are no bonds between the oxygen themselves, the hydrogen themselves, sorry. Now, we actually call these intramolecular bonds or molecular bonds. And that means they're within the chemical or molecule itself, so they're within the water in this case, and they're holding the water together. Now, I want you to try to remember that when we change phase, we do not, I repeat, do not bust these bonds. That's not what the energy is all about. There is another type of force, though, that goes between water molecules, and we show it as this little dotty thing. And this is between molecules, so we call it inter. Inter means between. So between two different things, between two molecules. So you'll see here, we've got this intermolecule or bond forming between an oxygen and a hydrogen. Then if they're close enough between another hydrogen, another water molecule, another oxygen, notice they're between the different molecules. So this molecule here is joining to this one, that joined, joining to this one over here, that joined, joined to this one, that joined, and joined down here to that one. And this quite often goes with all of water, and this is why certain things happen in terms of water when it freezes, because what we've got to try to do is to try to get all these little intermolecular forces and all the shapes that go with it. But that's a very complex issue, and we'll leave that one alone at this stage. Oh, by the way, we actually call these bonds in water hydrogen bonds. These intermolecular forces, we call them hydrogen bonds. Now, So what's that got to do with phase change or state change? Well, in a solid, all of these little atoms, these things here, are close together. These little molecules are close together, and they've got these little intermolecular forces between them. So when I add heat to it and melt it, what I'm doing is I am trying to break these bonds between the molecules, so the molecules or particles can move about more freely. All right, now the same applies to when I change from a liquid to a gas. In a liquid, the molecules are free, moving around freely, but they're a bit close together. And when I add more heat to them, I spread them out. So these intermolecular forces tend not to form. We weaken the intermolecular forces to such a degree that the atoms are able to basically move independently in gases. In a solid, these intermolecular forces hold the things in shape. And in liquid, it's halfway between. So this is why it's important for us to think about the bonds that are within a chemical and the bonds that are between lots of chemicals. Now, when we are changing phase, the ones we break and the ones we want to disappear are the ones between the chemicals, two chemicals or multiple chemicals, not the ones inside the chemical itself. I hope that's made it clearer.